Welcome to GVN Academy. Today we're going to look at Form 2 chemistry still, that is balancing chemical equations. Now we have been given some equations here to balance. Remember, not all well-balanced equations are correct. So how do you balance a chemical equation? For you to be in position of balancing a chemical equation, you should make sure that the number of atoms of each element at the product side must be equaling to the number of atoms of each element at the reactant side. And now in a chemical equation, this is what we call the reactants, and this is the product. So the reactants react to give the products. So these are the reactants, these are the products. So let me take you through balancing. The first question is saying we should balance the chemical equation, that is the reaction between sodium monoxide and water, which is giving us sodium hydroxide. Now at the reactant side we have 2 atoms of sodium, while at the product side you're only having 1. That means this equation is not balanced. So what are you supposed to do? We are supposed to make sure that the number of atoms of sodium at the reactant side is balancing with the one at the product side. So here we are having a 2, so there is a need for a 2 here. And by placing this 2 here, or inserting these 2 here, that means we have doubled the number of oxygen atoms. At the same time, we've also doubled the number of hydrogen atoms and sodium atom. So here we are having 2 sodium atoms, 2 oxygen atoms, and 2 hydrogen atoms at the product side. What over the reactant side? This 1 plus 1, there are 2 oxygen atoms, there are also 2 hydrogen atoms, and 2 sodium atoms. So the first equation here is already balanced. Coming to the second one, we're having the reaction between iron and steam, giving us triion tetraoxide and hydrogen gas. So at the product side, we are having 3 iron atoms, while at the reactant side, we have only 1. So there is a need for us to come and insert here a 3. Again, at the reactant side, we are having 1 oxygen atom, while at the product side, we are having 4. So we need to come and insert here a 4. So by putting a 4 here, we shall have multiplied the number of oxygen atoms here by 4. So we have 4 oxygen atoms at the reactant side, and also have 4 times 2, this is 8 hydrogen atoms. How many do we have here? We only have 2. How do we make these 2 number of hydrogen atoms to balance with these 8 number of hydrogen atoms at the reactant side? So there is a need for us to come and put here a 4. So we have 4 times 2, this is 8 hydrogen atoms, 4 oxygen atoms, 3 hydrogen ion atoms. So 4 times 1, 4, 4 times 2, 8, 3. So the second equation is also balanced. We go to the third one. Hydrogen burns in air, giving us water. At the product side, we have only 1 oxygen atom, while at the reactant side, we have 2. So there is a need for us to come and insert here a 2. By inserting here a 2, we shall have doubled the oxygen atoms. So we have 2 times 1. We have 2 oxygen atoms. 2 times 2. We have 4 hydrogen atoms. And yet at the reactant side here, we have only 1. So we have to come and again insert here a 2. So that 2 by 2, we have also 4 hydrogen atoms, the same at the product side. So this equation is also balanced. We come to equation, that is the D part, is saying lead 2 nitrate is decomposing to give us lead 2 oxide, nitrogen dioxide, and oxygen gas. Now, how are we going to balance this equation? Now, we begin by making this odd number of oxygen atoms here even. Why? Because at the reactant side we have already this 2 times 3, there are 6 oxygen atoms, and while at the product side we're having 2 plus 2 plus 1, 5, and this is an odd value. So we can begin by making this odd number of oxygen atom here even. How? By just inserting here a 2. When you insert here a 2, we now have 2 lead atoms, 2 times 1, 2 oxygen atoms, plus this 2, 4, plus this 6. And again, by inserting these 2 here, that means we have already caused a change in the equilibrium. So, in the position of the equilibrium, that means we need to also come and insert here a 2, because initially here we had only 1 lead atom. So, 2 times 1, we have 2 lead atoms here, here also 2. And again, by inserting these 2 here, we shall have doubled the number of nitrogen and oxygen atoms which are in lead 2 nitrate. So, this 2 by 2, 4 times this 1, So we have 4 nitrogen atoms, and yet at the product side we only have 1. So there is a need for us to come and insert here a 4. So that 4 by 1, 4, 2 by 2, 4 by 1, 4. So we have 4 nitrogen atoms here, and also here 4. Even the lead atoms are now balanced. 2 times 1, 2, 2. Let's come to oxygen atoms. This 2 by 2, this is 4. 4 times 3, 12. So we have 12 oxygen atoms at the reactant side, while at the product side we confirm. So this is 2 by 1, 2. 4 by 2, 8, plus this 2, that is 10. So this is also giving us 12. So the equation is now balanced. We go to the second last one. That is the reaction between hot turpentine and chlorine, which is chlorine acting as a reducing agent. Chlorine, reducing agent, reducing hot turpentine to hydrogen chloride. We are having 10 carbon atoms, and yet here we have only 1 at the product side. So there is a need for us to come and insert here 10. Also, we have 16 hydrogen atoms at the reactant side, while at the product side we only have 1. So there is a need for a 16 here. So that's 16 by 1, we have 16 hydrogen atoms. 16 by 1, we have 16 chlorine atoms. How many do we have here? Here only have 2. So how do we make this side also 16? So we need to look for a factor of 16, which when multiplied by 2 give us 16. So this has to be 8. So that 8 times 2, we get 16. So this equation is also well balanced now if you try checking the number of atoms present on both sides. Coming to the last one here, we are having the reaction between copper 2 oxide and ammonia. Ammonia acting as a reducing agent, reducing copper 2 oxide to copper, itself being oxidized to water, and there is formation of nitrogen gas. So at the reactant side we have 3 hydrogen atoms, while at the product side we only have 1. So this is an odd value and this is an even value. So what do we need to do? We begin by making this odd number of hydrogen atoms at the reactant side even. How? We insert here a 2. By inserting here a 2, we shall have also doubled the number of nitrogen atoms. So this 2 by 1, 2 nitrogen atoms, 2 by 3, 6 hydrogen atoms, and yet here we have only 2 hydrogen atoms. That means there is a need for us also to come and insert here 3, so that 3 by 2 we have 6, which is balancing with the one at the reactant side. So we have 2 nitrogen atoms here at the reactant side. At the product side you also have 2. So the number of nitrogen atoms now balancing. What of oxygen? By inserting a 3 here, we shall have increased the number of oxygen atoms from 1 to now 3. 3 by 1, 3. What do we need to come and do at the reactant side? There is a need for a 3 here. Why? Because we had only 1. So by putting a 3 here, we shall have again multiplied the number of copper 2 oxide by 3. So 3 by 1, 3 copper atoms, 3 by 1, 3 oxygen atoms. So there is need for us to also come and have 3 oxygen atoms. Copper atoms this side. So we have to also come and insert here 3. So when you try checking throughout the equation, you realize that the number of atoms of each element present at the reactant side is balancing the one at the product side. Thank you so much. We'll meet again next time when we shall be handling another area, that is ionic equation.